From coast to coast and worldwide on the Internet, this is Coast to Coast AM with Art Bell.
It is, and what a treat you're in for right now. Coming up in a moment, Dr. Michio Kaku. Dr. Kaku is an internationally recognized authority in theoretical physics and the environment. He holds the Henry Solomon, I hope I'm not slaughtering that, professorship in theoretical physics at the City College and the Graduate Center of the City University of New York. He has lectured around the world, and his PhD-level textbooks are required reading at many of the top physics laboratories. Dr. Kaku graduated from Harvard in 1968, summa cum laude, and number one in his physics class. Number one, received his Ph.D. from the University of California at Berkeley Radiation Lab in 1972, held a lectureship at Princeton University in 1973, then joined the faculty at the City University of New York, where he has been a professor of theoretical physics for 25 years. His goal is to help complete Einstein's dream of a theory of everything. That would be a single equation, perhaps no longer than 1 inch, which it is said will unify all the fundamental forces in the universe. That's quite a goal indeed. In a moment, Professor Kaku. Well, all right. A friend of mine, an amateur operator, Cliff, K7R, sent something to me, said he didn't know the worth of it, but he sent it to me. You know, these ham stations around the country have been experiencing this unusual absorption going on recently, which absolutely ruins shortwave, usually reliable communication. And we may have an answer for what's doing it. Here's the first article. The Chandra X-ray Observatory discovers the largest known explosion of immense size in space involving supermassive black holes. From Athens, Ohio, scientists have observed the largest explosion in space, a finding that would suggest that supermassive black holes, which produced this blast, are a bigger force to be reckoned with in the universe than previously thought. Again, I love that line. The study published in this week's issue of the journal Nature details the discovery of enormous cavities, each about 650,000 light years across, that's big, surrounded by hot gas in a distant cluster of galaxies. The two cavities, sounds like bad teeth, right, created by an outburst from a supermassive black hole could explain why some galaxies don't create new stars as they cool down in temperature, the typical recipe for star formation. Said Brian McNamara at the University of Ohio, an astronomer who's lead anchor on the research. So this was absolutely a monster of gamma rays. Now, in another article fortuitously sent to me, it's called Sudden Ionospheric Disturbances. Now, normally, radio operators and the ionosphere is controlled pretty much by activity on the sun, flares and such. And we always look to the sun when we're concerned about strange conditions. But lo and behold, quoting from this Sudden Ionospheric Disturbance article, it says, it was the initial explosion on December 27th that showered gamma rays into the Earth's ionosphere. So it begins, there have been several episodes over the past week and more of some very strange sudden ionospheric disturbances, or SIDS. Now, these have not been caused by solar flares or the like, but rather from GRBs, gamma ray bursts from very distant objects, like, several hundred light years away. The most recent event on December 27th, when a massive gamma ray burst hit the Earth at about 2130 UTC from a magnet star called SGR 1806. This GRB was so powerful that it was able to ionize our ionosphere just like a solar flare and cause ionospheric absorption right down to the VLF frequencies, very low frequencies. And Dr. Kaku, I've been searching for what in the world could be disturbing our ionosphere to the point that it ruins radio communications. And, of course, we always look to the sun, but lo and behold, here they're telling us it may be something like the collision of black holes, or what?
That's right. These are gamma-ray bursters, which may be generated by what are called hypernovas. Hypernovas are gigantic, supermassive, gigantic explosions in space that lead to the formation of a black hole. And there is speculation that perhaps on the other side of the black hole there's a white hole.
Oh,
and
really?
if the matter that falls out of the other side, you have a white hole that spews out energy. Huh. And there's even a theory that says that the white hole is actually a Big Bang.
Really?
That is, that we may be, and this is just a theory, we may be witnessing the creation of a baby universe, a baby Big Bang taking place, where our universe is actually fissioning, and the matter being sucked into the hypernova blows out the other end and creates a white hole, which excretes enormous amounts of energy. And, of course, that looks very much like a Big Bang, doesn't it? A tremendous amount of matter and energy spewing out of a single point.
Well, it does. And, Professor, we're short-lived beings. And in my life now, in modern days, it seems 2 or now 3 times, Professor, I've heard these stories about these sudden monstrous explosions detected, each one larger than the last one, and they compare them to the original Big Bang in strength in some way. And it's amazing, these things. What is this, Professor? Ongoing creation?
Possibly. We astronomers, the physicists, used to think that the dinosaurs were wiped out 65 million years ago by a nearby supernova that took place maybe 20, 30 light years from the Earth. That would be enough to scorch the Earth with an electromagnetic pulse. It would fry the ionosphere, boil the oceans, and it would be sufficient to wipe out the dinosaurs. However, we've looked, and of course, we have found the crater in Mexico that is the most likely candidate for the extinction-causing event. However, these gamma-ray bursters are more powerful than hypernovas. And so it's conceivable that if a nearby hypernova were to blow up and we're right in its path, then it could definitely cause atmospheric disturbances. A close one, like I said, would actually burn off our atmosphere.
So we would just sort of be incinerated instantly.
We would be fried, that's right. However, most of the gamma-ray bursters are in other galaxies, millions to billions of light years away, fortunately. However, their power is absolutely staggering, second only to the Big Bang itself. And we do believe that forming out of this is a black hole. And like I mentioned, there is a possibility that as matter gets sucked into the black hole, it has to go someplace, and it could blow out the other end, creating what is called a baby universe. And that is also, in part, the subject of my new book that I have coming out this week, In Parallel Worlds.
Oh, this week?
This week it's coming out, right. We physicists are speculating on what kind of conditions would it take to create another universe.
Yes, and it's called Parallel Worlds, a journey through creation, higher dimensions, and the future of the cosmos.
That's right. And so we believe that, perhaps in the future we'll be able to send probes in the distant future to some of these things to really analyze in detail the formation of hypernovas. Satellites today, of course, can photograph scores of hypernovas every day, but some of the big ones are truly staggering in their power. And with the Hubble Space Telescope, for example, we've been able to see black holes eating lunch, gobbling up whole star systems for lunch.
Yes.
They just gobble up stars and barely burp. That's how massive some of these black holes are.
Not planets, mind you. Remember, planets, folks, are like what we're on, that go around, suns, like our sun. And and the professor's talking about entire systems, suns with presumably planets, and all the rest of it just instantly sucked into a hole.
And in my book, I also profiled the fact that we physicists are now spending millions of taxpayers' money searching for evidence for these parallel universes. This is a rather new development just within the last few years. The idea of parallel universes is now a fairly well-established concept in the theoretical physics community. And as a consequence, now several experiments are being conducted right now to search for physical evidence from a parallel universe.
Well, you know, Professor, I know you'll toss your cookies but when I say this, but the concept of parallel universes was pretty well established by the metaphysical community long ago. And, of course, you know, I understand that what I'm talking about is not science exactly, but, in fact, people in metaphysics have been talking about something that approximates a parallel universe for a long time now, and now all of a sudden people like yourself are coming along and saying, yeah, in fact, it's science.
That's right. We're catching up in some sense. If you read the psychic literature going back to 1900, especially in England, you realize the Psychical Society there included physicists who would later win the Nobel Prize.
Really?
So physicists at the turn of the century, including Crookes of the Crookes tube, which is now called a cathode ray tube, which is found in your TV set, was very much interested in psychical phenomena around 1900. But, of course, the experimental data was lacking 100 years ago. Now we have satellites. We have gravity wave detectors. We have laser detectors. In the last 5 years, a real battery of scientific instruments are gradually coming online, which may once and for all establish the identity of a parallel universe. For example, gravity should go between parallel universes. We cannot jump into a parallel universe unless we have a looking glass. But gravity freely goes between universes. And as a consequence, by looking at tiny little deformations in Newton's laws of gravity, we should be able to detect the presence of a hovering nearby universe. So think of two parallel sheets of paper. On each parallel sheet of paper, you have ants walking and living and doing their chores, oblivious of the presence of the other. However, each ant has gravity. And as a consequence, if you get close to an ant in the other parallel universe, you can sense its gravitational pull. This means there should be shadow matter, a shadow universe, which should be detected by our instruments. Now, there are some astronomers who actually believe that this is the explanation for dark matter. Dark matter, it makes up most of the matter of the universe. It's invisible. It surrounds the Milky Way galaxy.
We have some clicking going on here of some sort. So dark matter, is dark matter that which is in between universes?
It could be matter in the other parallel universe.
Altogether in the other universe.
That's right. We realize now that surrounding our own galaxy, there is a sphere that weighs 10 times more than our own galaxy, which holds our galaxy together, by the way. It's very well established now that our galaxy should have flown apart. It should have been blown apart billions of years ago because it spins too fast. But what holds our own Milky Way galaxy together is a sphere of dark matter which surrounds it. But every time we try to photograph it, we come up with nothing. The Hubble Space Telescope has given maps of where dark matter should be, but there's nothing there.
Nothing there.
It's visible.
Should dark matter, in what manner would it be visible?
It bends light, and so the Hubble Space Telescope, by looking at the bending of light, like light going through glass, for example, has given us beautiful maps of dark matter throughout the universe, but there's nothing there. We look, and it's invisible. So there's an invisible matter that pervades the universe, which has gravity. And there are two theories about this. One theory is that it's shadow matter. It's matter from this parallel universe that's very close to our universe, and it has gravity.
So it has mass. It has real mass in another universe.
That's right.
And gravity, that mass is being exhibited as measured gravity.
That's right. That's exactly it. Gravity goes between universes, but light does not.
Gotcha.
Light and matter are stuck on each sheet of paper. The gravity freely goes between these universes because gravity is the warping of space. And therefore, by looking for invisible matter, we should see the outlines of objects in a shadow world. And the Hubble Space Telescope has given us beautiful, gorgeous maps of dark matter. And so one theory is that dark matter is the presence of shadow matter, dark matter existing just above us.
Shadow matter. So, in other words, this would be something you could conceivably, theoretically, I guess I had to say, you could theoretically see it, only we haven't yet.
That's right. The second theory is that this new type of matter, dark matter, is something made of something called sparticles, superparticles, which are higher vibrations of the superstring. So we could be listening to a new higher octave. We are the lowest octave. Neutrons and protons would be the lowest octave of the superstring. The next octave would be superparticles or sparticles. They would be invisible. And the second theory, also coming out of superstring theory, says that perhaps they're nothing but higher vibrations within our own universe.
Oh, God, I can't stop myself. Professor, I've got to stop you for a second for, again, something that will probably cause you to toss your cookies. But on this program, we've had these discussions involving what people have chosen to call shadow people. Just bear with me here. Here's the theory. These so-called shadow people are beings or something that we imagine to be perhaps from another universe. They are seen only very occasionally, sort of in the periphery of your vision. Just a very fleeting glimpse of these people. Now, get this, Professor. A lot of the people who claim to have seen these beings have been spending a lot of time in front of a computer and a computer screen. And as you know, a computer screen is refreshing at a certain rate. It's got a vibration to it, in a sense. The refresh rate is a vibration. And people theorize that their brains are somehow being, what's the right word, reset in some manner by this refresh rate, by spending hours and hours and hours and hours staring at a computer screen, and then finally being in a situation where you see something that you ought not see, that some people in the metaphysical community choose to call shadow people, and it sure sounds a little like that shadow universe you're describing.
Well, in my book, Parallel Worlds, I quote from H.G. Wells' famous novel, The Invisible Man. And in that original novel, a medical student discovers the secret of the fourth dimension. So if you have two parallel sheets of paper separated by the fourth dimension, and one person is hovering higher above your universe, he is invisible.
Right.
However, he can look down on your universe.
That's right.
The invisible man looks down from his sheet of paper onto yours, but light travels beneath him, so anyone in the lower sheet of paper sees nothing, sees something that's invisible. So that's how H.G. Wells explained invisibility in the original novel of The Invisible Man by the Fourth Dimension. Now, today we physicists are taking this idea very seriously. Like I said before, millions of dollars are being spent, taxpayers' money, grant money from the government, searching for disturbances, slight disturbances.
That would be the proof that you're hunting for, that there is that mass there.
That's right. Shadow matter, the presence of a nearby universe, perhaps a millimeter away. In the literature,
yes, sir,
physicists often talk about it being perhaps no more than a millimeter away, but invisible because it's hovering just above us. And even though we cannot send a space probe there because we're stuck on our universe, gravity freely goes between them. So the presence of the other universe may actually be felt in our universe. And like I said, this is shadow matter or dark matter. And dark matter, you can look in any astronomy book and you see whole chapters devoted to the mystery called dark matter, which somebody was going to get a Nobel Prize trying to figure out what dark matter really is.
All right, Professor, hold it right there. Oh, boy, if you could see the big smile on my face. A big, broad, Enzyte-like grin because of what he's saying and what so many of you have said. And I'm not saying one absolutely underwrites the other, but, I don't know, like Iraq and Vietnam, I see lots of really good parallels. From the high desert in the middle of the darkness, it's exactly where we do our business. This is Coast to Coast AM.
This is Coast to Coast AM with Art Bell.
Well, heck, folks, the ride is half the fun. People keep saying, are we there yet? Well, the ride is half the fun, and the ride is what you're on right now. Good morning, I'm Art Bell. My guest is Professor Michio Kaku, who is one of our nation's premier theoretical physicists, and the big broad smile I have is still there. To hear what all of you have said to me, and then to hear this coming from the professor, I don't know, there's just too many parallels. Wicket from Minnesota writes, yes, shadow matter, shadow people, parallel universes, upper and lower planes that someday we're going to be able to travel to. More from the psychic spiritual world. I've done it. I know. Or John, I myself sit at my computer at night, and every now and then I see these shadow beings out of the corner of my eye. I know. Eyes out there are rolling, and it goes on and on. Yup, I see shadow mice when I'm sitting in front of the computer. And I'm glad I'm not losing my mind. Well, Kathy, I can't guarantee that, but you never know. And people just go on and on. I get these computer messages, Tom, Johnson City, New York. Art, you just described me. I've been seeing shadows, spent an awful lot of time at the computer, so there's just, waves of agreement with that out there, and me too. I don't think it's so strange to imagine that what, for example, the Hopi have been saying, what others have been saying, things that we regard as lore and the metaphysical, things that people have seen that are inexplicable. If what Professor Kaku is saying right now, then maybe they're not so inexplicable. Maybe there will be a meeting of science and the metaphysical. What do you think? Okay, so gravity, if I'm correct, I think I am, is a function of mass, right? Gravity is mass, or it comes from mass. You have mass, you have gravity. And so what Dr. Kaku is saying, I think, is that we're detecting the gravity, which means something is there, but doggone it, we can't see it. But the fact that there's gravity there indicates that there's mass there. So that means there probably is another universe there. Dr. Kaku, if we tried to imagine what the nature of this universe might be like, is that so impossible as to not even be worth a try, or can you make guesses at what it might be like?
Well, this is a very active area of theoretical physics. We physicists create universes with our equations, and each universe, we think, could be a well-defined parallel universe. String theory predicts millions of different kinds of universes. And we think that our universe is one of the universes predicted by string theory. Millions, billions of universes can be found within string theory.
Would there be any similarity, do you suppose, in nearby universes? Would there be any commonality in the fact that they were nearby, or would the next universe be as likely as different as A to Z?
Well, most of the universes, we think, in the multiverse, in fact, that's what my book is all about the multiverse. In the multiverse, most universes are probably dead, in the sense they're lifeless. They probably consist of electrons, neutrinos, lightning bolts, but not much more than that. However, some of them probably look just like our universe. They probably have stable matter, stable protons, meaning stable DNA. And if you have DNA, then, of course, there's a possibility of creating life in these universes. And as we mentioned, there is one theory that says that when these hypernovas take place and all this matter implodes at one point, the matter blows out the other end, creating a universe which is actually quite similar. Well, quite similar to our universe.
Okay, all right. Remember when you and I discussed what might happen if you went back in time and committed a no-no of some sort, that instantly another universe would be formed, a bubble on a bubble, so to speak, something like that, right?
That's right.
Okay, well then, wouldn't it stand to reason that if time travel had been going on, we might be accompanied by several other universes that are very much like ours if there have been a series of time travel accidents.
Yeah, this is the many worlds theory.
Yes, sir.
In which case, at every event, the universe has to make a choice, and both universes spring into existence. This resolves the famous Schrodinger cat problem. That is, how is it possible to have a cat that is simultaneously dead and alive? In quantum physics, we do this all the time with electrons, and that's called laser beams and electronics. The entire electronic age depends upon the fact that electrons can be two places at the same time. They can disappear, reappear someplace else because of uncertainty.
Right.
And the entire electronic age does this. However, the question is, if electrons do that in a laser, can we do this as people? We are large objects, and can we be two places at the same time? And according to the many worlds theory, the answer is yes. That is, the universe splits in half every time a different kind of decision has to be made.
Well, that would create a number then of very similar but somewhat different in minutia. I mean, it could be the same except for some very small.
One quantum event separating us from that parallel universe.
One quantum event.
Like a cosmic ray that went through Hitler's mother. If a cosmic ray went through Hitler's mother and Hitler was never born, perhaps World War II didn't take place and 50 million people didn't have to die.
So there could be worlds in which a World War II never happened, Hitler never happened, but otherwise we... What?
In other words, in the many worlds theory, it says that in your room, in the privacy of your room, there is the wave function of dinosaurs. There's the wave function of aliens. There's the wave function of a world where the Nazis won World War II. Think of radio. In your room, there are many radio frequencies that fill your room, but your radio is only tuned to one frequency, the Art Bell Show. But you simultaneously exist with all these radio frequencies in the room, but you're tuned to only one. According to the many worlds theory, in the very room that you reside in right now, there is a wave function of dinosaurs, because that comet missed us 65 million years ago. There's the wave function of pirates, because pirates were not exterminated centuries ago. There's the wave function of Nazi stormtroopers beating down people's door.
Okay.
It's just simultaneously with these wave functions.
That's so fascinating. Before you would be able to transport a human being from one to another, as you pointed out, very complicated. But if we can have light in two places at one time, then somewhere along the line it seems like we could have information in two places at one time. So couldn't we imagine a situation where somebody invented, say, a television screen or, whatever it would be, plasma at least, I suppose, and we could look at a parallel world as it happened? In other words, the transfer of information.
Well, it's not so easy because according to string theory...
Well, I never said it was easy.
Right. According to string theory, our sheet of paper, we are prisoners of our sheet of paper. That is light, matter, electrons. Even though electrons dance many places at the same time inside our PCs, in our universe, they're confined like a prison to our universe. However, gravity is the only force.
I was going to say, what about modulated gravity?
Well, in my book, I actually discussed the question of what it would take in order to create holes, which would allow us to see what's on the other side of the universe.
Yes.
And to do this, you have to do what is called boiling space. If I have a microwave oven, for example, and I turn up the microwave oven, I boil water, I turn it up some more, and the water dissolves into hydrogen and electrons and protons. I turn it up some more, and the protons dissolve into quarks. I turn it up some more until I hit what is called the Planck temperature. At the Planck temperature, even space itself begins to boil. Space itself becomes unstable at the Planck temperature, and bubbles begin to form, except these are not bubbles of water, they're bubbles of space. And each bubble is then a gateway to another universe.
Holy mackerel. What is this Planck temperature, by the way?
Oh, it's fabulous. You're talking about 10 to the 19 billion electron volts, which is a quadrillion times more intense than more energetic than our most powerful atom smasher. But again, in my book, I speculate that far in the future, when the universe gets very cold, and the universe will die trillions of years from now as it gets very cold in a big freeze, civilizations do not have to die when the universe dies trillions of years from now in a big freeze. Civilizations will be type 3, type 4, type 5 by then, and they will boil space. They will create machines, and in fact, I give blueprints for what these machines may look like in my book.
Really?
Yeah, in the last chapters, I give detailed blueprints of the temperature, the size, the energies necessary to boil space, to create a microwave oven with enough temperature, enough pressures and temperatures and densities and energies, so that space itself begins to boil, wormholes begin to form, bubbles begin to form, each bubble being a gateway to one of these neighboring universes.
And an escape.
An escape. Now, I also point out that if you calculate the size of these wormholes, most calculations that we do show that they're very small. However, perhaps in the future, if they're just big enough to shoot molecules through,
yes,
an advanced civilization may shoot nanobots through this tiny hole. These nanobots are molecular robots, and they would land on an asteroid and create factories to create carbon copies of themselves like a virus, and they would form a DNA factory. And the DNA factory would then clone their own masters in this other parallel universe.
Holy mackerel.
So even though their bodies may perish as their old universe dies and gets very old, they may send nanobots through this bubble to a younger universe to recreate their race, which then leaves the question open.
Fairly egotistical on their part, I might add.
What happens if one of these universes dies and they go into our universe? Our universe is still pretty young.
Right.
We can see the end, of course. Our instruments can see the time when our universe will die. However, our universe is still warm and is still young. And perhaps one day, in desperation, a neighboring universe will send a lifeboat through one of these holes and visit our universe. And
they wouldn't necessarily have our best interests in mind.
Well, they'll be, by that time, type 4. They'll be beyond galactic. And I think by then they'll have resolved all their sectarian, religious, fundamentalist, racial passions. They will have had millions of years of existence since rising out of the swamp. And I would assume by then they will have the wisdom that goes along with this incredible technology of being type 3 or extragalactic being type 4.
But does even greater wisdom assure that it would be benign from our point of view? Not necessarily, right?
Well, we are type 0. We're quite savage in terms of our instincts. Whenever Arthur C. Clarke once said that there either is or is not intelligent life in outer space, either thought is frightening.
Yes, it is.
Either thought is frightening, because if there is intelligent life in outer space, we're suspicious of them. We get very antsy and very worried about their intentions.
Well, Professor, they should be there, shouldn't they? I mean...
I think they're out there. I think
indeed. From your point of view, with what you know about really what is out there, which is far more than the average person, to imagine that, just the sheer numbers alone wouldn't dictate that it would happen is almost unimaginable.
Well, in the year 2014, NASA is going to send the terrestrial planet finder into orbit. It will detect 500 Earth-like planets in neighboring constellations.
There you go.
And this is in 2014, not that far away, when NASA will have a probe sensitive enough to detect 500 Earth-like planets in nearby constellations. And we will have an existential shock with our little telescopes looking up, knowing that perhaps somebody's looking back at us from one of these Earth-like planets in outer space.
With that many Earth-like planets, what are the calculated odds that, or is there even any way of calculating such odds that at least one of them would harbor life?
Oh, well,
intelligent life.
In our nearby sector of the galaxy, that's what the terrestrial planet finder will find, these 500 Earth-like planets.
That's still quite a few.
Right. However, in the galaxy, the Milky Way galaxy has 100 billion stars, and we believe that about half of them, up to half, may have solar systems. The other half are probably double stars and therefore uninteresting. But perhaps half of the 100 billion stars in our own backyard have planetary systems, of which maybe 10% have Earth-like planets.
Why are the double stars uninteresting?
They're probably unstable. If I have like two stars chasing each other, like chasing each other's tail,
yes.
Two stars chasing each other,
right.
Then a planet would have to be very, very far away to orbit around this double star system. If it gets too close, it'll be ripped apart. So triple star systems are very uncommon. The nearest star to the Earth, by the way, is Alpha Centauri, which is part of a triple star system. But the nearest star to the Earth is a triple star system, but again, it's two stars chasing each other's tail, with the third star being quite far away. So a planetary system like that would be probably unstable. But we think that about half the planets, half the stars in the night sky are solitary, without partners, and that means that perhaps 50% of the stars you see at night could have solar systems, and perhaps 10% of them have Earth-like planets. And
so
like
that's a gigantic number then. So
it's astronomical.
Yes, so then a person like yourself would almost have to lean in the very high percentages that life is likely, right?
Yeah, I mean, there are, of course, reasons for believing that even Earth-like planets may be unstable. For example, you have to have a large Jupiter-sized planet accompanying it to throw out comets and meteors to clean out like a vacuum cleaner.
So you don't get destroyed by a rock.
Right. Also, you have to have a large moon because our Earth may actually tumble without the moon. The moon stabilizes the Earth. Without the moon, the Earth would have tumbled, making life very difficult on the Earth as the axis tilts and wobbles.
Okay, but again, just the sheer numbers alone indicate there are going to be situations like that.
Oh, I think it's without question.
I mean, even now, we're leaning toward discoveries that are suggesting there's life on Mars, microbial perhaps, but life on Mars. That's just our nearest number one neighbor. So if that's the case, then life must be common. If it's common, well, then, of course, I get down the line a little bit, and I say, okay, fine, then where the hell is it? Why haven't we heard somebody knock?
Well, my attitude is that if they really are type 3, that is, if they're galactic, and they really have the energy capable of going between star systems, which means they have access to the Planck energy, that would mean that the distance between them and us is like the distance between us and an anthill. And we don't visit anthills too often, right? We don't give beads to them, trinkets to ants.
No, but I mean, I'm sure that when you were a child, I know I did. I leaned down and I watched
on a few of them, right?
Well, I did, but mostly I looked at them and the industrious little suckers carrying these giant hunks of bread and stuff. It's interesting, so I stared at them.
But for how long? We're type 0. A type 3 civilization would stare at us for a little bit and then get bored very quickly. Wow. And then simply walk away. Type 0 civilizations are probably dime a dozen in the galaxy.
Why would you, it sounds like you imagine that a type 3 is benign, peaceful, past all of the political, religious hang-ups that the world has right now. Why do you make that assumption?
Well, because we evolved on a very savage Earth. Resources were scarce. Food was scarce, shelter was scarce, mates were scarce, and the way we got access to shelter and food and mates was by force. We have a very, it was only a short while ago, a few million years, that we were really savages in the forest. And a type 3 civilization would have had perhaps 1 million years of evolution away from their savage past.
Or that much savagery, and they're the winners. I don't know.
And the search for resources, the search for energy, the search for mates, that would not be first and foremost in their mind, I think.
All right.
So that's why I think that by the time the type 3, they are going to be benign.
Well, okay. Professor, hold on. We're at the top of the hour. Being the type 0 I am, I still have to take commercial and news breaks. That's all right, because it brings you all of this. From the high desert, this is Coast to Coast AM. I'm Art Bell.
This is Coast to Coast AM with Art Bell.
With one of the smartest people in the world. My guest is Dr. Michio Kaku, and he is indeed one of the world's leading theoretical physicists. It's fascinating to listen to, so I suggest you stay right where you are. Once again, Dr. Michio Kaku. All right, I guess we better do this. Mark in East Lansing, Michigan, obviously may not have heard our early programs, Professor, and simply asked, what is a Type 3 civilization life form as opposed to, say, a Type 1 you were just talking about? Please explain. Now, you've done that a number of times, but there are new people out there, so by all means.
Okay, and before I do that, let me just mention my webpage, if you don't mind.
Not at all.
It's www.mkaku.org, mkaku.org. And you can see a description of my new book, Parallel Worlds. And I'd like to thank Michael Phillips and Corey for setting up the webpage. They've done a great job monitoring the webpage. 40 million hits on that webpage so far.
40 million hits.
A fraction of your number of hits, of course.
I'm
sure a lot of my hits are spillovers from yours.
Happy to be delivering whatever hits you can take.
Okay. Well, briefly, a Type 1 civilization is a planetary civilization that harnesses planetary power. They control the weather. They would control earthquakes, and that tsunami, for example, that devastated the Indian Ocean, that would be easily controlled by a Type 1 civilization that controls anything planetary.
All right. Stopping there for a second, folks. He's describing a Type 1. We are a zero.
We're zero. We get our energy from dead plants, oil and coal.
Right.
We cannot predict we can barely predict the weather, let alone modify it or change it. We're at the mercy of earthquakes and volcanoes and tsunamis. A Type 1 is about 100 years away from us in technology, but they control planetary forces.
That's not very far, 100 years.
Not very far. You can see the beginnings of it. You know, the Internet is the beginning of a Type 1 telephone system. That's what the Internet really is. English will be the language of Type 1.
Can you even imagine, Professor, how a Type 1 might have, say, controlled or stopped or prevented or, I don't know, whatever, with that tsunami?
Well, first of all, they would be able to look inside the Earth. We're very primitive in terms of using earthquake waves to monitor the inside of the Earth. They'd be able to look inside the Earth and be able to predict well ahead of time and be able to release the energy slowly of these earthquakes before they build up. And we're at the mercy of these forces because we cannot see inside the Earth. However, with supercomputers, with sensors, and eventually neutrino telescopes, we may be able to actually see inside the Earth.
But how would even a Type 1 civilization control the movement of tectonic plates against each other? That's what it is, right?
Yeah, well, for example, it's known that if you flood certain areas, just ordinary water will loosen some of the fault lines and actually initiate some rumbles in the fault. They would be able to precisely, in three-dimensional geometry, locate where all the pressure points are and relieve them using water, lubricants, or whatever kinds of advanced technology they have. They would know exactly where the pressure points are, relieve them so they're not going to build up, so the tectonic plates slide over each other without locking.
Is there
locking of these plates?
Yes, is there research like that going on, Professor? I've heard little bits and pieces about injecting water and its effect.
It's very primitive because we don't know where the pressure points are. Just only in the last few years have we got the first map of the inside magma of the Earth. If you were actually to look at the core of the Earth and see all the streams of magma, it sort of looks like an onion with thin tendrils coming out of the onion. I was quite shocked when I saw that picture. We have just a rough approximation now of all the magma channels that are inside the Earth. Very rough picture.
That's fascinating.
Quite astonished when I saw that picture.
How far down do we have knowledge of?
Well, this picture was taken of the entire core of the planet Earth, and it was done by looking at supercomputer analysis of waves caused by earthquakes as they went through the planet Earth itself, bounced off different layers, and then using a supercomputer to reconstruct in 3 dimensions the shape of all the junk inside the Earth.
Okay, so this is kind of on a scale of what a geologist does when they're looking for oil. They drop some dynamite in a hole, they let her rip, and then they the vibrations come back and are put together by a computer.
Right.
Is that the same sort of thing?
And a Type 1 civilization would have monitors over the entire planet Earth and have very precise sensing devices that allow a supercomputer to then reconstruct the entire shape of the interior of the Earth. The magma in the Earth looks very much like a potato, by the way, with tendrils and vines coming out of it in all sorts of irregular ways.
Well, you say you saw that. Where did you see
this? It's been published in science magazines. I'll look for it, and maybe I'll put it on my website. But seismologists have been able to construct the first crude picture of the inside of the Earth.
Wow.
Now, Type 1 civilization would have an accurate description of all the pressure points and where all the tectonic plates are jammed, and be able to loosen them precisely, rather than using witchcraft and all sorts of different kinds of imprecise ways of trying to locate where the pressure is building up. And of course, the pressure is building up miles underneath the surface of the Earth.
Yes.
So a Type 1 civilization would have the energy, would have the know-how, the supercomputers, to accurately reconstruct not just the inside of the Earth, but weather patterns also. They'd be able to modify the weather, be able to stop hurricanes before they form. They would have a tremendous understanding of the weather patterns, and any planetary force they'd be able to control. Now, Type 2 has exhausted the power of a planet.
Before you start out on a Type 2, how much distance in time, Professor, would there be, say, between a Type 1 that we're fairly close to and a Type 2?
Between Type 1 and Type 2 is about 5,000 years. And you can calculate that number by looking at the rate at which the gross domestic product of nations increases. Energy consumption is very closely tied to gross domestic product, which grows at about 2% a year. And at a rate of 2% a year, we will hit Type 1 in about 100 years. We'll hit Type 2 in roughly 5,000 years. And we'll hit Type 3, which is galactic, at about 100,000 years to maybe 1,000,000 years, depending upon whether we can perfect warp drive. So this is the progression of civilizations. And, like I said, we're about 100 years away from Type 1. And every headline I see in the newspaper leads me to believe that we're seeing the birth pangs of Type 1. The formation of the European Union is a Type 1, beginning of a Type 1 economy. And they formed to oppose NAFTA, which is us, North American Fair Trade Agreement.
Right.
And culture is even becoming Type 1. Blue jeans, rock and roll, rap music. That's a universal Type 1 culture being formed right before our eyes.
Rap music is part of Type 1?
Beginning of a planetary culture. Blue jeans, rock and roll, youth culture is becoming universal and planetary. Also, there are people who, in their gut, understand that we're headed for Type 1 and don't like it. These are the terrorists. In their gut, they know that a planetary civilization is in formation, and they feel more comfortable living 1,000 years in the past at a -1 civilization. And so terrorism is a byproduct of the fact that we are marching toward Type 1. And I think that a planetary civilization is in the cards. You can see signs of it everywhere.
And do you think that those people who oppose our present momentum, Professor, would, if they could, destroy what's left of our Type 0 and 7/8 to prevent us from getting to Type 1? In other words, would they destroy the entire planet and all those who live on it if they had that capability to prevent the Type 1?
Well, I think that one reason perhaps why we don't see lots of aliens in outer space is that perhaps they did not make the transition between 0 and 1. That's the most dangerous transition of all time. By the time you're Type 2, you are immortal. Nothing known to science can destroy a Type 2 civilization. But Type 0s are extremely vulnerable.
Yes, being absolutely honest, this is the sad, hard-to-take part, folks. The hopeful part is that we could get to be a Type 1. The downside of this is that the odds of a 0 getting to a 1, especially through this dangerous period that we're in right now, are approximately what, Professor?
Well, my friend Sir Martin Rees, who's the Royal Astronomer of England, tried to make that estimate, and he put it at 50-50.
Oh.
Which I think is a little bit generous.
Oh.
But the Royal Astronomer of Great Britain put it at 50-50 that we'll make Type 1.
Well, it's extremely optimistic. Some of the numbers you imagined, I don't know, a year or so ago, much worse.
A lot worse, right?
Much worse, yes.
Yeah. However, like I said before, there are people who want to resist the transition to Type 1, and they want to get access to nuclear weapons, chemical weapons, biological weapons, and create all sorts of mischief.
That's right.
Not to mention global warming and all the havoc that could happen in the jet stream.
Let's do it. Let's mention global warming for a second. I just read a book that I'll tell you about after the bottom of the hour that was anti-global warming. It's a brand new book called State of Fear. I'll tell you about it. Anyway, if you look now at the north part of the world and the south part of the world, and you really look at these satellite photos that go back, 50 years or whatever, it'll just scare the pants off you. I mean, the North Pole is melting, the Antarctic is calving, and
Alaska is thawing out. Every glacier on the Earth is receding.
Yes. This seems so important to me, Professor, as though there's a change going on that eventually might not allow for, human life on the planet.
Well, maybe one day when we reach other planetary systems, we'll find that their atmospheres are too hot to support life because they had a greenhouse effect, or their atmospheres are radioactive because they had a nuclear war. So I think it's a warning to us that not every civilization makes it to Type 1.
Well, when you look at present environmental trends, are you encouraged or discouraged?
I think it's going to get worse before it gets better. I think it's going to take a major shock. I think it's going to take a major shock before politicians get off their butt and do something. We're talking about major storms that are going to inundate cities because of the rising of the sea level, the warming of the water to create hurricanes. We're going to see the disruption of the seasons so that, again, farmers are going to complain that their crops are devastated. We'll see dust bowls forming. We'll see mosquitoes rising north, carrying malaria. It's going to take a major catastrophe before the politicians do anything. And that's human nature, unfortunately. Humans don't do anything until they have to. But I think that's what's going to happen. Basically, nothing will happen until some catastrophe happens that threatens the breadbasket of the nations, swamps cities, inundates whole nations, and creates unmitigated havoc.
Can you imagine what sort of event or the magnitude of the event it would take to actually do that?
Well, for example, a nor'easter almost paralyzed all of New York City, where I live, putting water into the subway system.
Yes.
As water levels rise, New York City will not go underwater, but storms will easily loft water right into Manhattan and paralyze America's metropolitan center. Wall Street could be flooded. And again, sea levels will not inundate Wall Street, but storms will lift water right into the subway system and basically grind New York City to a halt. So I think things like that in San Francisco, New Orleans, Los Angeles, things like that will make the politicians really begin to wonder about this global warming business.
And you do anticipate an event of that magnitude?
I think that's what it's going to take. Right now, Alaska is thawing out. However, Alaska does not have that many electoral votes. Already in Alaska, we see the tundra beginning to thaw out. The highway systems are collapsing because the tundra underneath is melting.
Absolutely.
Apartment complexes are beginning to crack because their foundations are melting.
The news of what's happening in Alaska is not making it to the lower 48 in the way that it ought to be. What do you make out of that?
Well, unfortunately, the media is concentrated in places like New York City. So when Alaska thaws out, people say, well, it's nothing but a bunch of polar bears. But when Wall Street is underwater, I think people are going to think twice about this global warming business.
Well, they definitely would at that point. But right now, there are they're canceling traditional dog races because there's no snow. I got an email from a guy up at Prudhoe Bay. Earlier tonight, I read it. It's warm up at Prudhoe Bay. Let's see. Here it is. I see. Here he is. He's up at Prudhoe Bay at the oil field, and he's writing that it's raining up there right now. Professor, raining. This is January in Prudhoe Bay. Raining in Prudhoe Bay. That doesn't make sense.
Yeah, and the seasons are all getting knocked out of kilter. The early bird may not get the worm anymore because worms and birds have different cycles.
Yes.
And they're being set a kilter because the seasons are being disrupted now. Farmers are getting increasingly worried about when to plant their crops because of the changing of the seasons.
This lady called me in the first hour of the program from, I forget, somewhere in the South, might have been Georgia. Anyway, she was saying that there was black mold, this really weird black mold growing on the soy crops down there. And there were projections this black mold may make it to the Midwest within the year or so. It would affect many, many crops. Wouldn't this kind of thing, this mold or other weird little things like that, sort of be a sideshow event to a major climate change?
I think so, and wait till it starts to disrupt the economy. America produces food, exports large quantities of food, has tremendous bread baskets in the Midwest and California and Florida. Wait till the agriculture of this country is disrupted. Then you're going to see a lot of angry farmers taking it to the ballot box. So I think, the politicians are being very coy about this. This thing is not going to happen during my watch.
That's right.
So why should I worry about it?
That's right.
But, yeah, it'll happen. It'll begin to affect the ballot box as people's pocketbooks begin to get affected. And
we're not long-range thinkers.
No, and that's why, some people say that we're not going to make it a Type 1.
Well, wouldn't those people be the place to put your money?
Well, we'll wait and see. But,
I don't want to be that dark, but it just seems like maybe I'm not seeing the good parts of the course we're on right now.
Yeah, well, I think it's up to all of us to put a little heat underneath the rear ends of some of the politicians who say it's not going to happen in my watch, so I'm not going to do anything about it. Let the next politician take the heat for global warming. That's their attitude.
Well, what about other nations around the world?
Well, China's coming up really strong now in their economy, and they're under a lot of pressure now to get their act together to make sure that they don't start to belch tremendous amounts of carbon dioxide into the atmosphere.
But that is what they're beginning to do. I visited China. A friend of mine just got back a week ago from Shenzhen province, for example, which has now, I don't know, there were a couple 100,000 when I was there. Now I'm told there are millions and millions and millions of people in Shenzhen. And the amount of commerce would just scare you to death. So that's the direction they're going in. Right. In fact, they're beginning to take over. So
as the world industrializes, I think that we all politicians are going to have to wonder what kind of world are we going to live in. We're going to create a vibrant economy with a living standard that people can afford, and air that's breathable, and a weather system that we can predict and is friendly, or will the weather turn on us? That's a question that all of us are going to have to ask, but it's happening right before our eyes now.
Well, I can tell you this. It's only a microcosm at any given snapshot moment with regard to the weather, but the number of calls that I've been getting just from people around, well, the world, including Alaska. The Alaskans come on here and warn us like crazy. They say you wouldn't believe what's happening up here. But it's not, I don't know, somehow it's heard, but it's not registering, or I can't figure it out.
Yeah, well, I think that when I look in the night sky and look at all those planets out there that perhaps are lurking and perhaps harbor life, they may have had the same problem centuries ago, thousands of years ago, and some of them may not have made it.
Maybe that's why it's so dark out there and we don't have any signals yet. Professor, hold on. From the high desert, I'm Art Bell. We will be right back.
This is Coast to Coast AM with Art Bell.
It is, and my guest is Professor Michio Kaku, one of the brightest men in the world. And we're talking about all sorts of things that indeed impact our world. If you'll just stay right there, we'll be right back. Every now and then, it's very important to know what the other side is doing. Now, I, too, fancy myself to be an environmentalist. Michael Crichton has written a book, ostensibly, yes, fiction, but very much on the edge of fiction, much in the way that I think the coming global superstorm was framed. We made it fiction for a number of reasons, but there were nuggets of truth in it, as there are in Michael Crichton's book. But boy, I thought it was a hack job. Nevertheless, I like Michael Crichton as a writer, so I read it. It is the antithesis, of course, of global superstorm, and the essence of it is, and this is what I want to discuss with the professor. The essence of the book is, again, called State of Fear. And it's suggesting that the American people, indeed the world's people, must constantly be kept in a state of fear about something. Whether it's the communist menace, or it's, the Nazis, or whatever it is. The world must be kept in a state of fear. And the current state of fear being perpetrated is the environmental movement. And that the whole thing is absolute bunk. The environmental movement is bunk. And in this fictional story, environmentalists are seen to do things like, calving icebergs from the South Pole with bombs in order to forward affecting the weather, doing various things to show that the global warming is real. In other words, the global warming people are running around perpetrating these things in order to forward the idea that global warming is real when actually there's not an ounce of truth to it all. It's a remarkable book. You should read it if you get the opportunity, Professor. So there are a lot of people who believe that, Professor, that the whole environmental thing is absolute bunk, and it's just the state of fear that we need to be kept in. And I think it's time somebody said straight out whether or not this is real. I mean, if it's bunk and just a state of fear, then we should ignore it and pay attention to other things. Or is the whole environmental question a very real, pressing question, real or not?
Well, I think Michael Crichton is a very good science fiction writer. He writes these techno-thrillers. He takes the germ of truth and then blows it out of proportion, but they're techno-thrillers and they're science fiction. So I think we should treat this book just like that, as science fiction. However, you don't have to have eco-terrorists calve icebergs with dynamite. They're doing it by themselves. You don't have to have environmentalists create all the problems of Alaska, the North Pole, the South Pole, the glaciers. Mother Nature is doing that by itself because it's being egged on by human activity. And so I think that he's giving the environmentalists too much credit. It takes an enormous amount of effort to go to the South Pole and knock off an iceberg. I
wonder if he proposes the Alaskans en masse have turned their hair dryers on the tundra.
Yeah, and the atmosphere is heating up all by itself because of all the carbon dioxide in the atmosphere. When this debate was first emerging, I was a little bit skeptical myself. However, what turned my mind was a graph showing temperature and carbon dioxide level correlations going back 100,000 years. Mm-hmm. We can now go back actually several 100,000 years by drilling into the North Pole and South Pole and extracting ice cores. And by analyzing the weather patterns hundreds of thousands of years ago, you find that there's a lockstep between carbon dioxide and temperature levels, like a roller coaster, two roller coasters in lockstep, and it's peaking now. The 1990s went down as the hottest decade ever recorded in the history of science, going back 100,000 years.
That's right.
Now, you have to really be, I think, stretching it to think that humans had nothing to do with the fact that just now, because of the Industrial Revolution and just within the last 10 years, we've had the hottest decade ever recorded, going back, I think the record now is 400,000 years is the latest number I've seen. So I think that, to me, really clinched it. It's human activity. And it's not just, sun cycles, and it's not just weather patterns and normal fluctuations. We see the normal fluctuations going back hundreds of thousands of years. But why now? Why in the last decade? And 2004 went down as, the third or fourth hottest year ever recorded in the history of science.
All right, well, as a scientist, that convinced you.
Mm-hmm.
Somehow the charts didn't make it to the Oval Office morning briefing or something. At any rate, certainly the politicians haven't registered one little bit with them yet, not at all.
Well, there is a problem, and that is economic activity correlates with carbon dioxide.
Yes.
The United States produces 1/4 of the world's carbon dioxide, but it also has 1/4 of the world's economic activity. There's almost a 1-to-1 correlation between conventional wealth, the wealth of petroleum, and carbon dioxide production. And that's why, the people who do produce carbon dioxide, the oil companies, the coal companies, they're going to resist any measures to rein in their profits by tooth and nail.
Gee, though, Professor, it's just being realistic here for a second, and looking at China and looking at the other emerging nations that are coming in.
They watch Hollywood movies, and they want the Hollywood lifestyle.
They absolutely do, and it's headed in that direction, whether we like it or not. I don't see any force on Earth that can stop it.
And so instead of trying to resist it, I think we should go with the flow and get the nations of India and China to wake up to the fact that they're going to be sacrificing their future generations by, building coal plants and oil plants rather than going into conservation and solar energy and wind power and renewables.
But how do we convince them of that when we're having our success consuming our 25% or whatever it is of the world's reserves in this area?
Yeah, well, I think we're beginning to look like a bunch of hypocrites, right? On one hand, telling people that they have to get their act together, and, America's always lecturing other countries.
Yeah, it doesn't sell well.
And it doesn't sound good when we're the biggest spender in terms of carbon dioxide and dumping the most pollution in the air. It doesn't look good at all.
Well, so just for the sake of the conversation, we should assume that they're not going to take our advice, and they are going to proceed full speed ahead into probably being the leading, China, for example, leading emitter and user, and so forth and so on. So what I guess I'm interested in is, what does that mean, and how soon does it mean it?
Well, like I said, unfortunately, I don't see much happening with regards to the big nations until there is some kind of catastrophe that affects everybody. You realize that, 150 years ago, there were no sewer systems in the major cities of the world until there were huge cholera and disease epidemics that killed rich people as well.
Right.
And when that happened, then the rich people clamored to have a sewer system. Well, a little bit of self-interest was involved, but that's what it took. It took a disaster that wiped out rich people before the rich people of Paris and London decided to build their sewer systems. And I think it's going to happen that way, too. People that live in, have limousines and nice offices on Wall Street, they have beach houses. And when their beach houses get torn apart by monster hurricanes and flooded, I think they're going to realize that, hey, maybe there is something to this global warming business. But I think that it's going to take some kind of catastrophe before people wake up and the politicians feel the heat.
Well, at present rates of increased emissions and attendant global warming, would you take a guess, or do you know anybody who would take a guess about where the breaking point would begin to be, where we might have an event of the proportion you're talking about?
Well, I think Florida, with all the hurricanes, was a wake-up call, not in the sense that it was directly related to the greenhouse effect. It could have been a fluctuation. But we are going to have more monster storms like this, And, these people vote. And they're going to say, I can't get insurance. My beachfront property, no one wants to buy it. My nest egg for retirement just evaporated, and no one's doing anything about it. And just remember that hurricanes get their power from warm water.
Sure.
And the temperature of the water is heating up.
So these events, it could happen any time, 10 years, 20 years, 30 years. In other words, trying to get an idea of, with what we see in terms of the scale of development.
I think in 5 to 10 years, we're going to see monster disruptions of the weather. Look at Europe. There were tens of thousands of people that suffered, and many died because of the heat wave that paralyzed Europe over the summer.
Yes.
Many of them children and elderly.
Oh, yes.
And I think we're going to see more monster typhoons and hurricanes. Japan recorded a record number of typhoons. And Florida, of course, got hit so many times by hurricanes. And that's going to be commonplace. We're going to see very common extremes of weather, extreme heat, extreme wetness, and extreme drought. And I think that these things will gradually become part of everyday living. We're going to be used to the fact that Florida is unlivable. And so I think that these people are going to get very angry. Farmers are going to get angry that their foods are rotting on the vine and dust bowls are being created.
Well, you actually began to see a little bit of it after this last hurricane season. There were people who very seriously talked about, that's it. I'm out of here. I'm out of Florida. Well, I'm sure a lot of them after the hurricanes quit probably calmed down and remained. But if there was yet another year of this, or even worse, and it keeps getting worse, it wouldn't be very many years before people said that in Florida and meant it and just flat left.
Yeah, I think in 5 to 10 years, you're going to see major changes in property values, major changes in people's lifestyle and pocketbooks. And it's not 20, 30 years. We're talking about monster storms, extreme weather conditions like the drought and the heat wave that hit Europe, the drought that's currently affecting the Midwest. Right now I'm in San Francisco doing my book tour for Parallel Worlds.
Yes.
And we've had a monster set of rainfall in Northern California.
Yes.
Unprecedented, in fact.
Well, I'm 20 miles from Death Valley, Professor, and we've never seen anything like it. Roads are washed out. It's like pouring water on marble. It doesn't absorb. It's an amazing time we're having, but I'm always, I'm so afraid to say anything and relate it to a seemingly larger change because, of course, it's only a macro moment in the environment and the weather. It's just a weird moment. Given it's a weird moment, it's hard to convince people that it's part of a bigger picture.
Right. Well, it could be a fluctuation, but these fluctuations are going to become more commonplace. We're going to see more and more of these fluctuations. They're going to be more extreme because there's more energy driving these things.
All right, Professor. What about the critics who argue that, yes, greenhouse gases have increased before and the world has gone through many cycles of ice ages and so forth and so on, and yes, maybe we're moving toward an ice age or moving toward whatever, but, this whole thing about man's part in it is so absolute bunk. That's what the skeptics say.
Yeah, but you see, if you take a look at the weather conditions on the planet Earth, again, going back hundreds of thousands of years, it's peaking right at the time of maximum industrial activity. And scientists can now actually measure the increase in temperature almost day by day by looking at rush traffic. I read one release on the Internet showing that by looking at the carbon dioxide emitted by cars during rush traffic, you can actually see the micro increase in temperature during the daytime because of rush traffic. And weekends, it went down because no one drives their car on weekends so much, but on Monday, and you see these cycles. So we can even see it now day to day. Forget the 5, 10, 100-year cycles now. You can actually see it day to day in terms of micro changes in temperature because of traffic jams and the lofting of enormous amounts of carbon dioxide in the atmosphere.
Well, I wonder, though, if these are local changes or are they the larger picture? In other words, yes, sure, cities with asphalt and buildings and all the things attendant with cities, and then, of course, the emissions as well, and the smog and all the rest of it are going to have a sort of sub-environment that's localized pretty much. Does that translate to the world scale?
Well, it does in the sense that you can actually see now in the cities not a constant temperature, but the temperature fluctuations due to cars. You can actually see that now in the evidence. So it's just not asphalt. It's the fact that on weekends, temperatures drop a little bit, and on Mondays, temperatures rise a bit because of the carbon dioxide being generated right before our eyes by economic activity.
No question about it. What I'm asking is, does this translate to the world's environment, or is it a localized only condition?
Well, it shows that carbon dioxide will, in fact, in the real world, raise temperatures.
Oh, I see.
Some people thought that because of cloud activity, because water rises in temperature, creates clouds, clouds reflect the energy back into outer space. Therefore, you get a compensating fact that clouds will cool the Earth, and clouds are created by global warming. But we've taken that factor into account now, and we find that that's not enough. The temperature still rises, even with cloud activity reflecting light back into outer space. We still see the effect that man-made carbon dioxide has a net increase in temperature even with this cloud activity. That was one of the main scientific criticisms of the greenhouse effect.
Yes.
That there could be compensating effects.
That's right.
Like a cloud activity. But we also have positive feedback. When the tundra of Alaska melts, it releases methane gas. Methane gas is even more of a greenhouse gas than carbon dioxide, even more of a greenhouse gas. And so we have an accelerating greenhouse effect in Alaska as the tundra thaws out and methane gas is released, and therefore it accelerates this whole process.
Now, there are some who even say, hooray for global warming. I mean, I can see that it's bringing changes. I don't care if man's hand is involved. Frankly, where I live, this is just a metaphorical person out there. Where I live, I could use several degrees of temperature rise. I would love it. What do you say to those folks?
Well, I think as far as economic activity, Canada could be the main recipient of the benefits. They could have the next breadbasket.
There you are.
Blessed with the Midwest that has a tremendous breadbasket. That's going to turn into a dust bowl. The next breadbasket could be in Canada as Canada heats up. So, yeah, some nations may benefit, but it's not going to be us. Our temperatures are going to be more like Mexico. And Mexico is very hot, as you know, in certain parts.
It sure is.
And they don't have bread baskets like we have bread baskets in the Midwest. No, they don't have a corn belt and a wheat belt. And, Canada is going to have huge corn belts and wheat belts at our expense.
So it may well be, then, that a Canadian is absolutely justified in saying, global warming? Bring it on.
Yeah, at the expense of somebody else.
Yes.
And it could be us.
Yes. But could that Canadian be wrong, or is he totally right? In other words, yeah, sure, bring it on. And, in fact, he will be better off. Or would there be some other unexpected occurrences as a result of this?
Well, many other unexpected occurrences like a disease, malaria, dengue fever, diseases spread by vectors like mosquitoes will start to rise. West Nile virus was unheard of a few years ago. Now many metropolitan cities have West Nile virus. Many people think that's just the beginning as mosquitoes start to head north, as more diseases start to occur.
I'm one of those people. All right, Professor, hold on. We'll resume in a moment. By the way, yes, of course, we'll open the lines for Professor Michio Kaku, whatever subject you might like to probe. From the high desert, the soggy high desert, this is Coast to Coast AM. I'm Art Bell.
This is Coast to Coast AM with Art Bell.
Actually, I don't think it gets any better than this. One of the brightest men on the planet. Dr. Michio Kaku is my guest. He's a theoretical physicist, co-founder of the string theory, and an amazing man. In a moment, we'll get back to him, and we're about to start picking up some telephone lines. So stay right where you are. You know, it just hit me like a rock. I should interview Michael Crichton. State of Fear was a remarkable book, and just remarkable. And not just based on that, but what else he has done. So many of my favorites, as the professor said, he's a remarkable science fiction writer. But this is over the top. I should interview Michael Crichton. That would be a very, very, very interesting interview. So if anybody's listening at the network who pays attention to that kind of thing, mark me down. Find Mr. Crichton for me. And once again, Dr. Michio Kaku. And speaking, I eat books. I spend all my time reading books, too much time probably. His book, Parallel Worlds, A Journey Through Creation, Higher Dimensions, and the Future of the Cosmos. Just a baby, just coming out. You're going to be pretty prolific in the book world, Doctor.
Well, I hope to educate the public to the enormous revolutionary advances taking place just within the last 5 years because of all the satellite data that we have pouring in from outer space. And I think there are a lot of books out there to be written because our old viewpoint of a universe is going out the window. Uni means one, and it's going to be replaced by a multiverse or a megaverse. And that's the theme of Parallel Worlds, that we're way beyond the era of just speculation and idle dinner table chatter. We're now in the realm of hard science with satellites, gravity wave detectors, laser optics. All these experiments now are being brought to bear on the multiverse, which is...
when do you think it possible, Professor, that some sort of concrete... warm barrel evidence is discovered?
Well, it could happen pretty soon. First of all, in the year 2011, just 6 years from now, LISA will be sent into orbit.
Yes.
The most ambitious NASA satellite ever sent into orbit. 3 satellites connected by laser beams to make an equilateral triangle in outer space. The triangle will be 3 million miles across. And it'll be connected by 3 laser beams, making a triangle. And any gravity wave, like a gravity wave from a colliding black hole,
yes,
or even remnant gravity waves from the Big Bang itself, which is still circulating around our universe, that'll hit the 3 satellites, jiggle the laser beams, and immediately we should see the interference pattern of the shock wave of the gravity wave. Now, just remember that we have baby pictures of the Big Bang, but these baby pictures of the Big Bang are when the baby universe was about 300,000 years of age. So think of a baby being born. We now have pictures of the infant universe at about an hour after birth.
I know.
We want a picture of the Big Bang as it's emerging the uterus, as it's coming out of the womb. And the radiation from the instant of creation should have signals, perhaps, from other universes on the other side.
Huh.
The frequencies emitted by the Big Bang will have a fingerprint.
In other words, we should find anomalous magnetic activity.
Gravitational activity, exactly right. And the anomalous gravitational waves that LISA will pick up in 2011 should signal the possibility of parallel universes. So we don't have to create an atom smasher the size of the universe to prove string theory and inflation. We have an atom smasher. It's called the Big Bang, and the radiation is still circulating around the universe. It's very faint, but LISA should be able to detect it because it's a huge observatory, 3 million miles across, connected by laser beams that will be so sensitive it'll pick up the signature of string theory. We should be able to verify the presence of higher dimensions in parallel universes, we hope, once LISA gets off the ground. And then in 2 years, in 2007, outside Geneva, Switzerland, the largest atom smasher conceived of by the human mind will be turned on outside Geneva in 2 years. It's so big you can put the city of Geneva inside it. It's that big. It's huge. And we should be able to smash atoms to recreate conditions not seen since the instant of the Big Bang.
Wow.
And I personally hope that we find sparticles out of the atom smasher, super particles. And these would be, again, the higher octaves of the superstring. And if we find that won't nail superstring theory to the wall, but it'll give a tremendous boost to superstring theory and the theory of higher dimensions if we find sparticles. That'll be the first hard evidence that this is the correct way to go.
That'd be a big moment. All right.
That's right. Echoes from the 11th dimension.
All right. Joel in Houston, Texas, has a couple questions. One, is it theoretically possible to unleash the energy in a string in perhaps the same manner that a nuclear reaction, in other words, a weaponized reaction or a controlled reaction, unleashes what we used to call blinding energy in an atom?
Yes, in the sense that atoms themselves are made out of strings. All the particles we see in the universe are probably nothing but modes of a vibrating string. And when the string snaps, when the string changes vibration, it releases energy.
Right.
So the energy we see from the sun is actually energy released from strings that are vibrating at a different frequency, in a different mode. And that energy is seen to us as sunlight. That's also the energy of the stars, the energy of hydrogen bombs. And the ultimate energy is the Planck energy. That's the energy of the string itself.
Right.
And that's the energy at which universes are created. That's the energy at which baby universes form. And so once a Type 3 civilization has access to the actual string energy, we should be able to release cosmic energy, the energy of interdimensional space.
Since we're talking about Type 3s for a second again, a couple questions in that category. Don't you think a Type 3 or even a Type 2 would want to play with, study, experiment humans, much like we do orangutans?
Possible. The Federation of Planets, like in Star Trek, they're a typical Type 2. They've only colonized a tiny fraction of the alpha sector of the galaxy. They live in mortal fear of the Borg, which is a Type 3 civilization.
Right.
Or the Q, which is Type 4. And it's conceivable that if there's a nearby Type 2, they would have colonized a few nearby stars. And if we are within that radius of a Type 2, then it's conceivable, that we could encounter a civilization just a few thousand years ahead of us that doesn't have a star-spanning empire, but only has colonized a handful of stars.
Huh.
And that would be a Type 2. And if we're within that close distance, then we may be able to make contact with it. But to really span the galaxy, that would require Type 3 to do that.
James in Indiana has another Type 3 question. He says, true, a Type 3 civilization would be uninterested in us, but at the same time, wouldn't a civilization that's been evolving for millions of years be facing problems of space for their large population, perhaps, and looking for planets to colonize? Though they might be uninterested in us, we might have an interesting place.
Well, they would terraform different planets. Many Earth-like planets out there probably only have microbial life and just germs, basically. And they would have huge oceans and resources and energy supplies. So there are plenty of planets that have just microbial life on them. So I would suspect that by the time you're Type 3, you really get energy from the stars. You don't get energy from planets anymore. You don't get energy from coal and oil. That's Type 0 thinking. A Type 3 civilization simply gobbles up whole stars. They put stars in their gas tank.
So it would look at least occupied from their point of view.
So again, I think they're going to be benevolent in the sense that we are savage because evolution drives us to have resources and mates and food and shelter. They've already solved those questions. By the time you're Type 1, they've already solved the question of food supply and shelter for their people. And we're talking about an immortal civilization, a civilization that is unstoppable by the laws of physics. Nothing known to science can stop a Type 2 or a Type 3 civilization.
And we're so close.
We're so close to making that transition, but so far.
To the phones, quickly. First-time caller line, you're on the air with Professor Kaku. Hi.
Hi, Art and Dr. Kaku. I've enjoyed all your books immensely.
Thank you.
Your next one. I have a couple of questions for you. Would the multiverse, and I've read some of the things that Dr. David Deutsch has written about that.
Right, at
interesting work. Would the gravity that you talked about earlier from the other universes, would that ultimately cause our universe to be closed and ultimately collapse rather than facing a heat death? And my other question is...
Well, one at a time.
Oh, okay.
Just relax. Go ahead, Doctor.
Okay, well, David Deutsch at Oxford talks about the multiverse in the sense of a quantum computer. Ultimately, silicon computers will be obsolete. Silicon Valley will turn into a rust belt. And the next Silicon Valley will be a quantum valley that uses quantum computers that actually compute in these other universes. But in my book, Parallel Worlds, I talk about the cosmology of these universes, That is, what would it take to actually live in a parallel universe? Could you actually create a machine that could boil space and open up gateways to such a parallel universe? And as far as the heat death or the big crunch, we believe that our universe will not have a heat death or a big crunch. It'll have a big freeze, entropy death. It's going to freeze to death because of something called dark energy. Dark energy is going to blow the universe apart. Our universe is accelerating. It's not slowing down at all. Think of a soap bubble that's expanding. We used to think that our soap bubble universe is slowing down, but it's speeding up. And as it speeds up, it's going to get very cold, so cold that all intelligent life will eventually die. And that's why I advocate that any type 3 or 4 civilization build a machine to literally flee to a parallel universe that's a lot warmer. So I think that if there is a neighboring universe, then perhaps we should flee to it billions of years from now, and we have plenty of time to do that, because no life form can exist when temperatures reach near absolute zero. That's the law of physics. It's a law of physics that all intelligent life in our universe must die unless we leave.
Caller.
Okay. My other question is, how will we reach type 1 status in the near future when we're facing global peak oil production? How will we overcome that to get to type 1 status?
Oh, now there's even a big argument about whether there is peak oil or not. There are many saying peak oil is now or about to be either way, and there are others who say hogwash.
Well, there is something called Hubbard's peak. And if you just take a look at the graph, the charting the amount of oil that we've taken out of the earth,
yes,
it does look like a bell-shaped curve, and we're at the top of the bell. Now, whether it really is a bell or not, we don't know, but we seem to be on the top of the bell-shaped curve right now, which means it's all going to be downhill from now. And just remember that Hubbard predicted back in the 60s now, that U.S. production would peak, and everyone thought that he was Cassandra and a Chicken Little. Yes. He was right. U.S. production did peak exactly when he said it, and applied to the world now. The world seems to be obeying the same bell-shaped curve, and we're at the top of it, which means that from now on it could be downhill, which means that we have to go to renewable resources like wind power and solar power and hybrids. Yes. And hydrogen power.
Well, the critics say, oh, nonsense. It is the horn o'plenty for oil, and it will always be there, and what is this baloney that we're going to run out of oil? Never.
Well, we'll always have oil because we'll always find oil with new finds, but the rate at which we find oil is decreasing now. I repeat, the rate at which we find new oil supplies is decreasing, and the total production is a bell-shaped curve, and we're at the top of the bell-shaped curve. Now, who knows what's going to happen in the next decade? But it's ominous, just like it was back in the 60s when Hubbard first predicted this for U.S. production. Now, world production is undergoing the same transition that the U.S. went through back in the 1960s, and that gives you pause because it could cause a major economic disruption of our economy unless we begin the transition slowly now to an economy free of carbon. It's a warning, basically.
Yes. Wildcard Line, you're on the air with Professor Kaku. Good morning.
Good morning. This is Tony from San Antonio. It's a real thrill to speak with you and Dr. Kaku, Art.
Welcome.
My question is about the holographic universe.
Mm-hmm.
Are we holograms? Where are we stored if we're holograms? Are we in these brains or membranes between the dimensions? I'd like you to talk a little bit about that, and I'll listen on the air, Doctor.
Yes, believe it or not, that's a hot topic amongst string theorists right now as to whether or not we really are ghost-like holograms of another universe. This idea was first proposed by Jacob Bekenstein decades ago when he looked at a black hole. The information stored on a black hole is proportional to its surface area, that is, the area of its event horizon. Mm-hmm. Now, when you throw a book into a black hole, you would assume that the information grew by the volume of the book. However, it doesn't go that way. The information of a black hole grows as the surface area. Gross. So you can really judge a black hole by its cover. So this means that a two-dimensional surface encodes all the information of a three-dimensional object. Now, this means that perhaps there's an ultimate limit to how much information you can store in a given area. Now, the movie The Matrix, for example, asked the question, can you put the universe on a CD-ROM? Can all the information of the universe be coded in a finite number of digits and placed on a CD-ROM? If Bekenstein is right, then the answer is yes. Perhaps the universe is a hologram. It can be placed on a CD, a gigantic CD.
Wow.
And maybe some kind of deity puts the CD in some kind of CD player and has pressed the play button. And here we are on the Art Bell Show because someone has pushed the play button.
But we're just marionettes on strings.
Now, string theory adds yet even another twist to it.
That's part of string theory.
Yeah, the biggest thing in string theory in the last 5 or so years is the holographic universe. This really startled string theorists, but it turns out that a 4-dimensional universe can be encoded in a 5-dimensional universe. Now, we used to think that these dimensions are totally different, but now we find that you can have a holographic projection onto a 5-dimensional universe. So in other words, there are some people who make the claim that perhaps we are in a hologram, that perhaps we're nothing but images of another universe. And
isn't such a claim just designed to give us a big headache?
Well, the math is there. I mean, when I saw these results coming out of Princeton, at first I said, no, it can't be. But I looked at the math, and my God, that's what the theory seems to predict.
That's where it came from, Princeton?
It came from the Institute for Advanced Study at Princeton, right. And the holographic universe idea is just jumping out of string theory right now. Several hundred papers have now been written on the subject. You can go to the web and look at what is called anti-de Sitter space holography. And anti-de Sitter space conformal field theory duality is a very fancy way of saying that perhaps we're all holograms, and perhaps somewhere out there there's a CD-ROM with our universe written on it.
So you're saying you can buy into the math behind this concept?
Yeah, well, we have to follow the math. We don't have experiments to test string theory yet, because, of course, LISA will be the first attempt to test some of string theories, and also the LHC in Switzerland will be the first attempt to test aspects of string theory. But the math is incredible. No one thought that a holographic universe would emerge out of string theory, but there it is in bright daylight.
Has anybody ever asked you, Professor, if LISA goes and does its thing, and string theory were to get blown out the window, what would your fallback position be?
Well, we physicists don't do physics for the money. We don't do physics because we want to have our name written in stone someplace. We do it because it's fun. We can't imagine doing anything else. So even if string theory turns out to be the theory of nothing rather than the theory of everything, it has already generated so much gorgeous mathematics, so many brilliant insights into the structure of things, that I think it will live forever. It will live forever because it has opened up so many doorways.
All right, Professor, hold it right there. We're at the bottom of the hour with Professor Michio Kaku. Always an absolute adventure for the mind. String theory, yes. That would be us, out at the end of the strings, being jerked around like little marionettes, going through life as a CD-ROM in the sky dictates. Yikes. We'll be right back.
This is Coast to Coast AM with Art Bell.
You're on tour this morning with one of the greats, Dr. Michio Kaku, who is one of the world's greatest theoretical physicists. And the latest idea is one to really contemplate. Actually, if you are a really avid reader, I would suggest you go grab his new book. But a week this book has been around, or will be. Parallel Worlds. Everything we've been talking about this morning, Parallel Worlds. A journey through creation, higher dimensions, and the future of the cosmos. Pretty big stuff, actually, huh? In a moment, we resume. Don't touch that dial. Professor Kaku, isn't this holographic scenario going to be utterly disagreeable for most people unless it's the old man with the beard that pushed the play button?
Yes, some people may find it hard to believe that the movie The Matrix could have anything to do with the world of theoretical physics. But yes, we physicists realize that black holes are holograms. String theory has given added credibility to this. You can actually calculate the information of a black hole, and sure enough, it's proportional to its surface area. It's proportional to a sphere, and it's finite. There's a finite amount of information you can cram into a black hole, which means that, in principle, you can digitalize reality.
Wow.
And under Newtonian physics, for example, the weather cannot be predicted. There's simply too much information necessary to code for the weather. So that's why we have chaos theory. Chaos theory was created to handle the fact that Newtonian mechanics cannot predict the weather. However, now we have the fact that in quantum physics, black holes are holograms. They encode all information on the surface of the event horizon. And Bekenstein even calculates that perhaps a Google 10 to the 100 is the total amount of information content necessary to create the entire visible universe. That's the first attempt I've seen to actually calculate how big a CD-ROM you need to encode all physical reality.
And that was how many times bigger than Google?
A Google 10 to the 100, a 1 with 100 zeros after it.
That's a lot of
That was the first estimate for the amount of information and necessary to code the universe. And this is all in my book, Parallel Worlds.
And well, I forget, it was about a week away? Is that
this week?
It's this week.
It's coming out this week. If you're at the bookstore, you'll be some of the first to get a copy of my book. I'm on a book tour right now. I'm in the Bay Area, speaking in Los Altos and Palo Alto and San Francisco. And then I'll be heading on to Chicago later this week and Washington, D.C. next week.
Is there a lot of people there in the Bay Area? Is there any place people in the Bay Area and its surroundings can go to get the times, dates, and all the rest of that?
Well, you can go to my website, for example, mkaku.org, mkaku.org. Tomorrow, around noontime, I'll be at Stacy's Bookstore in San Francisco.
Really?
Tomorrow night, I'll be in Los Altos at the Main Street Forum in Los Altos. Tuesday morning, Tuesday night, I'll be at Café Scientifique at Palo Alto. And Wednesday, I'll be doing a lot of radio interviews with NPR.
That's very ambitious.
Yeah, it's a city a day, and so I'll be hitting a lot of cities. And then in February, I go to England, and I'll be touring the United Kingdom.
Do you enjoy it? Book tours are serious matters in terms of plunking down right in the middle of your life and changing it.
That's right. It's a big disruption. You're hitting a city a day. You're doing radio in the morning and afternoon,
right.
And then at night you're doing a lot of book signings, and the next day it's another city.
That's right. How do you feel about that?
Well, when I was a kid growing up, I wanted to know about, the fourth dimension and time travel and the unified field theory and Einstein, and I couldn't find any good books. There was just nothing out there at all. And I vowed that when I grew up, and I became a theoretical physicist, that I would write books that the average kid could understand so that they didn't have to go through the same horrible process I went through as a kid, knowing that there was good stuff out there, knowing that the universe was fantastic, incredible, beyond comprehension, and yet no good books could explain them to me.
Well, now there are.
Right.
But that still didn't, I'm not sure that answered how you feel about being on tour.
Well, it's rough, but it only lasts for, 2-3 weeks.
So you can see the light at the end of the tunnel.
That's right. And you can also see the joy in young people's eyes when you make contact with them.
Of course.
That feedback, I can see why politicians love the idea of, pressing the flesh, because you get a feedback, you get a sense of energy. And when I meet these people and they tell me that finally, a credible answer is given for all the questions they have.
Must be very satisfying.
Yeah, it's very gratifying.
All right. First time caller line, you're on the air with Dr. Kaku. Hi.
Hi, this is Sheldon in Santa Maria, California, listening on 1240 KSMA.
Yes, sir.
I'd like to go back to the many worlds theory.
Sure.
I was thinking that if you're creating new realities with the same person in each reality, and they all have the same identical mind in each parallel world, could it be that the human mind itself may be a quantum computer?
Well, a quantum computer is a computer that is made out of individual atoms, and by changing the spins of these atoms, it performs a calculation. So in that sense, the mind is probably more like a neural network, which is what is called a learning machine. However, the mind itself exists in a quantum universe. So the mind itself is not a digital computer. It's not a Turing machine. The mind is a neural network. It's a learning machine. There's no Microsoft in your head. There's no operating system. There's no subroutines. Your brain has no operating system. There's no Windows for the brain. The brain is a learning machine.
Thank God.
However, real quantum computers, we think, will be developed perhaps in the next several decades. The first one was developed a few years ago, but full quantum computing won't come for a few more decades, and that will replace the silicon computer when it takes place. So I think the mind is a neural network, but it does exist in this quantum universe, where conceivably in one universe you're dead, and in another universe you're alive. So in some sense, your loved ones in another universe are still alive.
Excellent.
Again, the science meets the metaphysical in a way. It's so amazing. Wildcard line, you're on the air with Dr. Kaku. Hi.
Hi, Dr. Kaku. Hi, you have a great program.
Thank you.
Many years ago, when I was in my 20s, I'm in my late 50s now, I spoke to Dr. J. Allen Hynek when I was living in Illinois.
Yes.
And my question to him was, Dr. Hynek, what are the chances in this vast, unlimited universe of ours of there not being other life forms similar or more advanced to us?
That's a fascinating way to put it. Let's put it to Dr. Kaku. Doctor?
Well, I think the chances of intelligent life in outer space is perhaps 100%. I bet the house on it.
100%?
I think 100%. I bet the house on it.
Well, I guess in a way you might be. You might be. I mean, if you look at string theory, it almost, with the alternate universes, it almost demands it.
That's right. You can count the number of stars in the visible universe. There are 100 billion stars in our galaxy.
Yes.
And we've counted. There are 100 billion galaxies in the visible universe. So the entire universe consists of 10,000 billion stars. That is the total number of stars in the visible universe as seen by astronomers. And it's hard to believe that we're the only ones with intelligent life on it. Among these 100 billion times 100 billion stars in the universe. And plus, if we have a multiverse of universes, many of these universes in the multiverse have stable DNA. They have autocatalytic self-replicating molecules like DNA. Mm-hmm. And they would have life forms on them, too.
The numbers almost seem, with multiverses, the numbers go beyond calculation almost.
It's beyond calculation, in fact. Yeah. So I bet the house on it, that there's intelligent creatures out there, probably even type 3 civilization.
There you go. East of the Rockies, you're on the air with Dr. Kaku. Hi.
Hi, this is Jeffrey calling from New Orleans.
Yes, Jeffrey.
Because I have so immense differences with Dr. Kaku, it wouldn't be enough time to go through them, but I'll say it very simply. Because I accept the supremacy of the law of identity, that which is what it is, I have a lot of problems with string hypothesis because it hasn't been proven objectively by experiment or observations in physical reality.
All right, well, what about Lisa? I mean, do you consider that a good chance for proof?
That's only one of many things that has to take place. To give you an example of the differences, when I look at a cycloplex, which you call a black hole, what I find is that it's a dark star with the gravitational field being strong enough to prevent light from escaping, rather than some kind of a hologram, which leads me to polyuniverses, which I can't even detect. And as far as I'm concerned, the only universe we've got right now is the universe we're living in.
Okay.
Well, look at it this way. Black holes used to be considered science fiction. For decades, science books would say that one day we will find a black hole in space. Now the Hubble Space Telescope has photographed hundreds of black holes in outer space.
It sure has.
And the Chandra X-ray Telescope, in one sector of the universe, has registered millions of black holes in outer space.
By the way, Dr. Kaku, can you make any case for a manned mission to save Hubble? Is that something we should be doing in your estimation, or have we gleaned as much information as we can reasonably get from Hubble? Is it not worth the trouble? What do you think?
I think it's definitely worth the trouble. We have telescopes coming online now on the Earth that rival the accuracy of the Hubble Space Telescope.
Is that right?
I know these telescopes actually compensate for the thermal disturbances in the atmosphere that cause twinkling of the stars. The stars don't really twinkle. It's the atmospheric disturbances that causes the light to waver.
So we've done what? Come up with software to...
Well, we have laser beams. Laser beams that are shot in the atmosphere, and the laser beams register all the thermal currents, and then we can compensate by taking the mirror, chopping it up into pieces, putting a motor on each piece. And so we have a flexible mirror that realigns itself millisecond by millisecond, and that way we can have near crystal clear pictures of astronomical objects without having to worry about the atmosphere so much.
That's absolutely incredible. I did not know that, number one. And does that then account for some of the scientific... disinterest in fixing Hubble?
Well, there are some people who say that we don't need to save Hubble because we have this new generation of telescopes on the Earth.
Are you one of those people?
No. I think that Hubble is $1 billion spacecraft that has done a lion's share of work. It has not even passed its peak yet in terms of what it could discover. And why throw away a perfectly good instrument which has given us gorgeous photographs of black holes and supernovas.
Oh, it has.
And planets and stars. So I definitely think that we should save the Hubble Space Telescope. Otherwise, it's $1 billion waste.
That's a lot of money. West of the Rockies, you're on the air with Dr. Kaku. Hi.
Hi, this is Armando from Ventura, California.
Okay, you're going to have to yell a little bit. You're not too loud. Go ahead.
Okay, I'm sorry. I had a question for the both of you. That's okay?
Sure.
I was wondering if you were aware of a man who was doing a virtual map of America with astrological markers.
With astrological markers?
Yeah, early Americans found astrological markers like these huge cones, these huge stones placed.
No, the answer is no. I wasn't aware of it.
Okay. I was trying to find his name again.
Okay, no, I'm sorry.
Dr. Kaku.
Yes.
I hear parallel universes, but I was just wondering if that meant a direct reflection of our material world, of what we see now, or is it possibly in phases, like more relative to what's happening at the moment?
We're talking about real universes that you can move in. These are not virtual universes on a computer, but real worlds with perhaps real people and real beings living in them. And like I mentioned, we physicists have talked about several mechanisms by which we may be able to move to some of these universes. And in my book, I end on a speculative chapter where I actually give you the blueprint of what a machine would look like that would allow you to go between universes. But these are real spaces. They're not fictional, and we believe they exist. And like I said, the Large Hadron Collider is going to be turned on in 2 years. LISA will go up in orbit in 6 years. And it's going to be the biggest game in town now, with billions of dollars of hardware that may detect echoes from the 11th dimension.
If that happens, how hard will it rock the physics world? Oh,
I think it'll be like a tidal wave that hits the physics world. Sorry for the illusion. But I think it's going to rock physics to its core. We have something called the standard model of physics, the quark model, in other words. It's been around for 30 years. Right. No improvement on the standard model in 30 years. But it's the ugliest theory known to science. 36 quarks and Higgs bosons and leptons and neutrinos and all these horrible particles put together in what is called a standard model. I like to think it looks like an aardvark with a giraffe and a shark scotch taped together and then calling it nature's finest creation of evolution. It's a horrible theory, but it works. It's the most successful theory known to science, accurate to within 10 billion, 1 part in 10 billion. But we want to replace it with music. The standard model would simply be the lowest octave of the superstring. And so Einstein spent his years searching for the mind of God. We now have a candidate for the mind of God, and that is cosmic music resonating through the 11th dimension. That is probably what the mind of God is.
The mind of God.
And that's what string theory promises us, the ultimate theory of everything.
One more call. International line, you're on the air with Dr. Kaku. Good morning.
Good morning. How are you today?
Fine, sir. Where are you?
My name's Dave. I'm calling from Ontario, and I have to tell you, being able to get through and listen to your show today has been an amazing blessing for me. First of all, when you said Canada's going to be a great place to live, you know what? That kind of worked for me a little bit. I've been living here for 30 years and kind of sick of these winters, to tell you the truth. But on another note, I was just wanting to ask Dr. Kaku to introduce the subject. I believe I was on the receiving end of light coming through a wormhole. That is to say that I saw what I ended up researching to be a galaxy. It was about the size of a quarter at arm's reach. Kind of a long, complicated story, but to cut to the gist of it, if wormholes were something that are standard in our universe, swirling around us all the time, if we were looking down, or up into a wormhole, will we be able to recognize the space that we see through the wormhole as space, as in local space?
All right, but hold it right there, and let's get the answer. We're way short on time, Doctor.
Okay, a wormhole would look like the looking glass of Alice. If I have a rotating black hole, it makes a ring, and the ring spins rapidly so it doesn't collapse. The centrifugal force keeps it afloat. And the ring would be the frame of the looking glass, so that if you stuck your hand through the ring of the black hole, your hand would wind up on the other side of forever. So it would look like conventional space, but at the center of the ring, you should see light coming in from an alternate universe. That's what we think would look like if you passed the event horizon and looked at a wormhole very, very close.
Does anything that goes into a wormhole come out?
Something comes out called Hawking radiation. When you throw a book into a black hole, it emits a very faint glow, which contains, we think, the information of the book, and that's called Hawking radiation.
It's what I wanted to do with Michael Crichton's book, but I couldn't get it there.
Oh. But anyway, we physicists believe that there is a chance that there is a wormhole at the other end of a black hole, because if you throw stuff into a black hole, it has to go someplace, and it could, in fact, blow out in a white hole, and the white hole, we think, could be a Big Bang.
It has been an honor to have you here. It always is, and as soon as you can come back, we'll have you back. What can I say? I hope they go out and buy your book. I hope you enjoy the book tour, and you're going to meet a lot of very nice people.
Okay, thank you so much. It's a real pleasure being on your show.
Take care, Professor.
Mm-hmm.
Good night. That's Professor Michio Kaku, no doubt. One of the great minds in this world we live in. All right, ladies and gentlemen, I think we'll take a bit of a break and come back and do this again tomorrow night as we carry you through the weekend. Or actually, you carry us through the weekend. That Coast to Coast AM weekend. I'm Art Bell from the High Desert. Good night, all.